Welcome to Energy Frontier, the Wyoming Landscape Podcast. Hosted by Dr. Holly Krutka, Executive Director of the School of Energy Resources at the University of Wyoming. The show highlights SER's role supporting our mission to promote energy-driven economic development for the state of Wyoming.
Today, we're learning about the Nuclear Energy Research Center at the University of Wyoming School of Energy Resources. Nuclear energy is an extremely powerful source of energy that is low carbon, but it's often misunderstood or not fully understood. So today, we're going to talk to two experts that tackle nuclear energy from different perspectives and explore the process for generating nuclear energy, risks and benefits of the technology, where we are in Wyoming, and what we're doing here at the University of Wyoming to grow our academic portfolio in this space. So thank you so much for being here, Tara and Caleb. Let's start by having you tell our listeners about your backgrounds and your roles here at the University of Wyoming. So Tara, let's start with you.
Hi, thanks for having me. I'm Tara Righetti. I'm a professor in the College of Law, the School of Energy Resources, and the Haub School of Environment and Natural Resources. And before coming to UW, I worked in the oil and gas sector, but here my research is focused mostly on administrative regulation of advanced energy technologies.
Thanks, Sarah. And Caleb?
Yeah, I'm Caleb Hill. I'm the J.E. Warren Professor of Energy and the Environment in the Department of Chemistry here, and also co-director of the Nuclear Energy Research Center. I'm a chemist by training. My background is in a variety of things ranging from catalysis to solar energy conversion and separations, which is kind of where my work overlaps with the nuclear energy work that we're trying to drive here at the university.
And appreciate that. So you mentioned you're co-directors of the Nuclear Energy Research Center. I think this is the first time we've ever tried to have co-directors that were coming from very different disciplines for a single center, one of our centers of excellence. Can you tell us about the center and the kind of work that you aim and how you work together, having come from very different backgrounds?
I think the model of NERC is very unique in that we incorporate people both from technical sciences and social sciences in leadership and in the work that we do. And that really takes this perspective of energy, because those are the disciplines that we're going to need to solve energy problems. They're not just technical problems. They involve questions of law, of regulation, of social acceptance, business and commercial. And you have to bring all of that together. And that's what we're really trying to do with NERC, is to connect with and connect researchers across the university and kind of bring everyone under one umbrella.
Perfect. Caleb, you probably didn't expect to be co-leading a center of excellence with someone with a law background, but you are now. And I think you said it well, Tara. Like, not just nuclear energy, all sources of energy do have technical and non-technical challenges. And I think you both have done an amazing job working together and building the Nuclear Energy Research Center and starting to build capacity across the University of Wyoming. So first of all, thank you guys so much for doing that and for working together and probably stepping outside your comfort zone on some of these issues to work with folks with a different background. So really appreciate that. So nuclear energy is complex on the policy side, regulatory side, social science side, and on the technical side. So Caleb, we'll start with you. Can you describe the general process for generating nuclear energy, and in particular, what's different from a conventional power plant?
Sure. I mean, the main thing to remember is that the only real distinction when it comes to generating nuclear energy is the heat source. You're still going to be heating up a liquid, spinning turbines, doing all the usual stuff that you're doing when you're burning coal or gas. You're just using a different source to generate that heat input outside of combustion reactions. So in a nuclear energy plant, your heat source is going to be generated through nuclear reactions that occur in the fuel that you put in to the reactor core that, in all existing systems operate on fission-based chain reactions that generate that heat. But outside of that, everything is pretty standard.
I think that's really interesting. And of course, most people have heard of the Terra Power Natrium project in Kemmer, Wyoming, where a first of a kind advanced reactor will be built. And they've done a really good job of explaining that there is the core nuclear technology, but actually even physically, the rest of the plant is separated. And I do think that's due to regulatory issues or limiting the amount of nuclear specific space on the plant site. Is that right, Tara?
Yes. So the strategy that TerraPower has articulated is called decoupling, which is really the idea of separating out the power generation facilities, the ones Caleb was talking about in terms of spinning turbines and boiling water, from the heat source. And that, from a regulatory perspective, is significant because the Nuclear Regulatory Commission, that's the NRC, has jurisdiction over those parts that pertain to radiation and those nuclear reactions. But if you can actually have full separation and decoupling where the things that are happening in power generation aren't part of the defense and safety plan for operations of the heat source, then those pieces are outside what gets regulated by the NRC. That's significant for a couple different reasons. First, it creates the possibility of being able to begin construction earlier. Otherwise, you can't begin construction until you have an early site permit. And it allows you to use some off-the-shelf commercial products in your facility design. And then on a maintenance and operations standpoint, there's some impacts from decoupling for that too. So the regulatory implications actually can make the project faster to deliver and less expensive.
Great. And I'm glad that we're talking a little bit about the TerraPower project because that was really a call to action when that got announced. At the University of Wyoming, we've long done research on the geologic side. So some people probably know that Wyoming is the nation's largest producer of uranium. So we have a lot of geologic expertise around our uranium reserves and what might be needed to support an industry producing that uranium, although it's still relatively low production levels today. But we didn't have a lot of expertise in other areas of the nuclear sector, including areas you both talked about already. So our answer to that challenge, what are we going to do to be engaged more on nuclear-specific work, was to stand up the Nuclear Energy Research Center. We put out an RFP, and you two applied to be co-directors and were selected for that. And then you had to set to work to start building capacity across the University of Wyoming. So Caleb, we'll start with you. Can you talk about how you kind of looked at the university as not a totally blank slate, but definitely needing to grow its research and instructional portfolio around nuclear energy, and how did you tackle that really from, not a big foundation to start with?
Yeah, the main thing that was missing when NERC was started is we didn't have any dedicated programs focused on nuclear. There's a variety of faculty across different departments in the sciences and more in the humanities that were doing nuclear relevant work, whether it was specifically on nuclear problems, like in my case, chemical separations, but also that just have a lot of expertise that could be leveraged towards new nuclear focused projects if they were given the right motivation and support. So when we started things up, a major focus has been to just support the development of new nuclear-focused research programs by the faculty that are currently present here so that we can get our students engaged, to develop new course offerings so that we can start to build a nuclear curriculum to prepare students that are here to engage with the sector once they leave, and to build the infrastructure that's going to attract more faculty and more students that are going to work in these areas moving forward.
Anything you want to add, Tara?
Yes, I think something that is really fun about NERC is that Caleb and I come from very different backgrounds, and we're not really doing research together. So much more of what NERC is about making connections between people, between institutions, and building partnerships. And so what we've been able to do is, like Caleb said, is connect people on campus, make sure that we have the capacity and infrastructure to support and grow those research programs, but then also building in really good connections with state agencies, with industry, with Idaho National Lab. And so all informing the work we're doing really to create a lot of energy and a hub here on campus.
Great. So Caleb, what would you describe as the pros and cons of using nuclear energy?
I mean, the pros of nuclear energy are that it's a baseline energy source capable of supplying grid-scale electricity that's naturally free of carbon emissions. So if we want to have clean baseline energy that's produced, we can do that directly using nuclear without having to worry about carbon capture or anything else.
Not worried about carbon capture.
Do we have to redo that?
No.
Okay.
Tara, is there anything about your work or other work you've seen coming out of the University of Wyoming or your engagement across the state that would lead you to believe that Wyoming is a good fit for nuclear energy? And if so, what?
Okay, first I want to answer Caleb's question.
Okay.
About the pros of nuclear energy.
Go ahead.
One of the things I think that also is really important about nuclear, if we look at decarbonizing our electricity sector, is that nuclear energy creates heat, which is necessary for a lot of industrial applications, and most renewables don't do that. And so that's a part of our energy system that can't be replaced with renewables. And to my knowledge, it either has to come from nuclear or from a combustion source.
Okay. So, Tara, what about Wyoming makes it a good fit for nuclear, or is it a good fit for nuclear energy development?
So I think the most important thing that makes Wyoming a good fit is that there's an openness and curiosity among the people in Wyoming to looking at and exploring and learning about new energy sources without some of those quick judgments. Some of the work that we've done here have shown pretty high levels of social acceptance, but also an even bigger group of people who say, I don't know enough, and I'm interested in learning more about this. And that's really exciting because that's the space where there's an opportunity for NERC, for SER, to help communicate what these new technologies are in advanced nuclear and provide information that allows people to make informed decisions about their personal opinions and about what's right for their communities.
Great. So, Tara, tell us a little bit about the nuclear-specific work that you are undertaking as part of NERC, as part of your research portfolio, and how it fits into the nuclear energy research system as a whole.
So right now, I have 3 projects that I'm working on that are specifically tied to nuclear. 2 of those are funded by the NEAP program, which is part of the Department of Energy. The first one is called Open Architecture for Nuclear Cost Reduction, and it really looks at applying principles of modularity and open architecture, which really focuses on the interfaces between separate modules. It's been used really successfully in the defense sector and really successfully in the tech sector to lower costs and promote faster innovation of technology. So we are looking at what that concept would look like if you were to apply it to the design and regulation of nuclear power plants.
What do you mean by module? Like, what would that in this context mean?
So the decoupling example that we shared is a great example of creating segmentation along regulatory lines. So that really creates 2 modules, and the interface between them is what kind of maintains the separation. You have one which is subject to regulation by NRC, and one that would be regulated under other federal laws and state laws. I think it's really important to say it's not unregulated, it's just regulated differently. Another example would be that if you were to create a module that would be like your reactor building, or your heat source could be a module that you can more or less plug in to other standardized parts with these kind of core interfaces. 2 examples I think are really helpful is you can have lots of manufacturers of fire hoses, and it doesn't matter who manufactures the fire hose, that you can go in and screw it into a fire hydrant. And that's because there's a standardized interface. And so that allows innovation and development of the different modules, which could be the fire hydrant and the fire hose, but as long as you keep the interface the same. So we think this will promote cost reductions and promote innovation. You can almost think about it, and this is the second example, is like you could sort of assemble the different components of a nuclear power plant like a Lego set.
Cool. That was the best description of that work I've ever heard.
Good.
I highly recommend the fire hose analogy. Okay. So, and Caleb, can you talk about your research that you're leading in your program and where that fits in? What problems are you trying to solve in the nuclear sector, separate from necessarily building this more capacity through NERC, but like what are you trying to tackle?
Yeah, so my research group specifically works on two broad areas. Both are currently funded by the National Nuclear Security Administration. Our first is in developing tools to enable the analysis of micron-scale particles for going through and doing nuclear forensic studies of enrichment levels in materials, which is a real fun thing to think about. And then the second broad thrust within the group is focused on separations problems. And those separations problems are relevant to both forensic applications and application to the back end of fuel cycle problems. So there's a big potential and I think general heavy push both within this country and elsewhere to look at methods that will allow us to do some chemical processing of used nuclear fuel after it comes out of reactors, both as a means to kind of alleviate some of the burdens associated with storing that fuel and possibly producing reprocessed fuel that could be further employed in reactors again to get more value out of the material.
And when you use the word forensics in
Yes.
this context, what does that mean?
Forensics means being able to go through and determine what is in something without any prior knowledge.
Perfect. So historically, there's, of course, concerns about the safety of nuclear energy and some misunderstanding. I'm not sure it's as prevalent in Wyoming, but we've also not hosted a nuclear energy plant before. So first of all, how safe is nuclear energy compared to other forms of energy production?
It's actually very safe.
Okay. Why do you say that?
There was a study that showed that I think you were more likely to be hit by a meteor than to die in a nuclear accident. But I would say there have been a lot of technical improvements in the last 30 years when we haven't been building a lot of nuclear power plants that are making them much safer. And they're addressing some of the problems that have led to nuclear disasters in other areas, particularly about what the cooling systems look like and whether they're walk-away safe, which would mean that there was a loss of power or a loss of water, you could walk away from it and it would still shut down safely.
And I think that that's a really key point. So I don't want to talk about any specific technology, but what happened, for example, in Fukushima is that pumps that circulate water that cool the reactor lost electricity. And the new technologies being developed now are designed in such a way where you don't have to have pumps to do cooling. If there was a pump and it lost electricity, it still has a way to, it's called passive cooling, so that the reactor wouldn't heat up even if you lost electricity to your basic system. So I think there is a lot of improvements that have happened and excited to see where that goes forward. But what can we do to restore public trust or maintain trust as we move forward with different nuclear technologies? Tara, do you want to take that one?
Sure. I think first and foremost would be focusing on education and really just having an informed public and trusting people that if you provide them with good information, they have the capacity to understand and absorb it. I think one of the challenges has been that there's such a divide between the people who understand nuclear and the people who don't. And it's really hard then for us to be informed citizens, to participate in political, processes and make choices about our energy system. So I'd say more information and making that more accessible would be a great place to start.
And one of the things that we're working on in conjunction with the Nuclear Energy Research Center is trying to grow our instructional offerings around nuclear energy here at UW. So just a quick plug that thanks to support from Idaho National Lab, we were able to, for the first time, to offer a Fundamentals of Nuclear Energy course last fall. And it was a very challenging course, especially for an elective, and we had over 20 students, so there certainly was demand. So now we're looking at other options. So we think that there's certainly interest from our students. So Caleb, you've been instrumental in starting to develop an idea, the concept behind a certificate program that would be focused on the technical side. And then I think down the line, we might try to do one on the non-technical side of nuclear. So just specifically, if we are able to develop this nuclear certificate, first of all, explain what is a certificate and what are we trying to accomplish offering a technical one focused on nuclear energy?
So a certificate program is something that could be taken in conjunction with a undergraduate or graduate course. It could also be obtained independently by postgraduate students that are just looking to come back and get a little bit of additional certification in an area. The goal with a nuclear energy focused certificate program here at UW would be primarily to, provide what we would call technical nuclear literacy to our undergraduate and graduate students, particularly in this first iteration that are pursuing degrees in technical disciplines, so that they are familiar with the principles of nuclear energy generation. They're familiar with the basic traditional and emerging reactor designs and concepts, and that they're familiar with other kind of surrounding subjects such as materials employed in nuclear systems, chemical challenges associated with fuel cycle concerns, and then policy issues surrounding nuclear power development as well.
And I think that actually related to that certificate, it is, if we continue to develop that certificate, it is focused on the more technical disciplines. However, I'm really excited and want to thank you for working together to have a non-technical course that those students could take, because understanding some of the regulatory challenges is only going to help students that take that certificate, and understanding some of the non-technical issues. It gives a good big picture. So thanks for working on that. So we'll see where that goes. So Tara, there's one more grant that you received focused on engaging with communities about siting of nuclear power plants. Can you talk about that work and what you've learned so far and what you're trying to accomplish?
So in that work, what we're trying to do is understand how Wyoming communities engage in the siting processes. So what we've started with is looking at where are the opportunities for public participation along the entire chain of development of a nuclear generation facility. So that would start with the grant potentially through the Advanced Reactor Demonstration Program, going through the NRC licensing process. It could also include state industrial siting processes or local government regulation. And so first, we're trying to catalog where are the different touch points where these projects create an opportunity for connection with the communities they're being built in. And then we're looking at how do Wyoming communities engage and participate in those? Do they have the information that they need? And, are they aware of them? And how could those be better structured for future projects? Our hope is to sort of develop a guideline of best practices for what engagement could look like, and that could then be incorporated into future projects.
Great. So, Tara, what's a favorite place you like to visit in Wyoming, or something you like to do here?
So my family and I really enjoy getting out into the mountains and exploring all the different mountainous regions of Wyoming. We've had an ongoing project to try to visit all of the Wyoming glaciers, and that's brought us to some really cool places, and just is a great excuse and region to get out into kind of rugged and undeveloped spots.
Awesome. Caleb? Okay.
I'm so bad. I go nowhere. I don't enjoy the outdoors.
You don't like anything. I hate everything.
Wyoming person in the world.
Caleb, when you're not in your desk, where in Laramie would we be likely to find you?
Well, either at my house or at the ice rink with my boys.
Nice. Do they play hockey?
They do.
Okay. Perfect. I really appreciate you both being here today, and for your leadership in the Nuclear Energy Research Center and actually many other areas across UW. Thank you guys so much for being part of School of Energy Resources, and for your hard work and for talking to us today.
Thank you for listening to this episode of Energy Frontier, the Wyoming Landscape, the podcast that highlights the School of Energy Resources at the University of Wyoming. You can expect a new episode of Energy Frontier every Wednesday on Apple Podcasts, Spotify, or wherever you listen to podcasts. See you next time.